Alkanols, which is one of the organic compounds in the homologous series. But first and foremost, at the end of this study, you should be able to define alkanols with its functional group, mention other organic compounds which belongs to homologous series, and should be able to classify alkanols into two, and should be able to mention one or two properties and preparation of alkanols. So let's go into the matter of the day. What are alkanols? Now, to take you back to previous lessons, we talked about homologous series, and we said that we have up to 10 families that belongs to homologous series. One of them is alkanes, alkynes, alkynes, and all these ones are saturated and unsaturated. So after those three basic hydrocarbons, that will launch us to alkanols. Now, one of the basic things about alkanols is that it has general formula of CnH2n plus 1 OH. One of the fundamental things about alkanols is that OH, hydroxyl group. It is that hydroxyl group that determines the chemical properties of any alkanols members. OH is joined to the alkyl group, and the two simplest forms of alkanols are methanol and ethanol. Example is methanol and ethanol. Following the CN, the CnH2n plus 1 OH. Here you notice that methanol is the first member of alkanols with N equals to 1. So when you substitute that 1 into this formula, you will come up with CH3OH, which is the molecular formula. Why this is the structural formula of methanol. The same thing goes with ethanol. Now, what are the other members of alkanols and the skeletal structures? There are different ways of representing any organic compounds. We have the skeletal structure, we have the scissor structure, we have the condensed structures, and you have other way of representing it. We have been able to mention 3. So the most common one, we also have staggered structure. The most common ones is condensed and general structure. So these are the other members of alkanols: ethanol, propanol, butanol, pentanol, estanol, heptanol. So every member of alkanols would definitely be identified by OL. So you always name it after OL. That's alkanols, methanol, butanol. So what are the preparation and properties? But before that, let me give you 2 or 3 fundamental properties, especially when we talk of reactions. We have oxidation, dehydration, esterification. But there are different ways of preparing alkanols. You can prepare alkanols by fermentation method, using the fermentation under the presence of some enzymes, which later you get to know. Now, what are the classes of alkanols? Alkanols are classified into 2 types. Base, number 1, it is based on the number of hydroxyl groups attached to alkyl group. So, number one, when you have one OH attached to alkyl group, we call such alkanols monohydric alkanols. When you have two hydroxyl groups attached to alkyl group, we call such alkanols dihydric. When you have three OH, we call such alkanols trihydric. When you have more than three, it becomes polyhydric alkanols. So quickly go over this quiz question. State one example of alkanols in each case. So I'll give you just 1 minute. Think about it and see what could be example of monohydric. Probably you draw the structure, you write the molecular formula. So while you are doing that, let's consider the second type of the alkanols. So this is classified based on the number of alkyl group, such as methyl, ethyl, and so on and so forth. You know that alkyl is formed by removing one replaceable hydrogen from alkanes family. So when you have one alkyl group, such alkanol is known as primary alkanol. When you have two alkyl group, such is known as secondary alkanol. When you have three alkyl group, we call it tertiary alkanol. So when you are asked to give types of alkanols, the major type of alkanol is that second classification, which is determined by the number of alkyl groups. So looking at the structure below, see primary alcohol is also known as primary alkanols, which is first degree, second degree, tertiary is third degree. Now, looking at the structure, you will discover that this one has one alkyl group, two alkyl groups, three alkyl groups. So 1, 2, 3, 1, 2, 1, just 1. Now, looking at the structure that represent primary alcohol or alkanol. Now, look at this. We have this. Don't count from the carbon which OH is attached to. So that one stands as a kind of a background of that structure. So the second carbon, count it. The all other one, just look at how many alkyl group. It only just is the carbon attached to that will define this type of alkanol. Look at this, the red determines by OH. So this is 1. Now look at this, the OH is already brought from here to the second carbon. So that second carbon will not be considered as the carbon that determines the type of alkanol. So you count the first carbon and you count the second carbon, that is 2. Then look at the third one, 1, 2, 3. So the red carbon determined by OH location. Now, what are the physical properties of alkanols? So, generally speaking, in inorganic compounds, you must have had you must have had acid and bases, which is known as alkalis. Now, you know that chemistry is divided into organic chemistry and inorganic. So in inorganic, we know then an acid and base. Like acid, anything dissolve in water and give hydrogen as the only positive. The same thing in organic compounds. So the most prominent organic basic is alkanols. So each time you see alkanols, look at it as a base in an organic form. So number one, they are colorless at room temperature and they are free-flowing fluid with fruiting odors. Now, in inorganic, most inorganic bases are solid at room temperature, but these are liquid at room temperature, especially the first 10 members of alkanols. So When you look at higher members of alkanol from carbon-12, they are solid at room temperature. Their boiling point are relatively higher than alkanes due to the ability of ethanol and other alcohols to form intermolecular hydrogen bonds. So when you look at alkanols, what makes alkanol significant when it comes to reactions is that OH. When it comes to reaction of property is that OH. Now, when you look at all other organic compounds, most of organic compounds are low in terms of reactions. So they need catalysts to be able to speed up their reactions. Only alkanols, alkanoids, and some other one form from this that they do not need any aid or any assistance of any catalyst to be able to speed up their reaction. Number one in alkanols is as a result of that OH. That hydrogen can easily be bonded with any other compounds coming from any other side. So that is why hydrogen bond. So as a result of that hydrogen bond, the boiling point of alkanols are relatively higher than alkanes. Now, looking at the lower members of alkanol, looking at their solubility, the lower member of alkanols are more soluble in water due to the presence of hydroxyl group that can form hydrogen bonds with other molecules, other water molecules. Now, water molecules, looking at water, is a universal solvent, and despite that it's a universal solvent, is also a polar solvent. So a polar solvent dissolves a polar solute. Now, almost all organic solvents are not polars except alkanols and alkanoic. So since they are not polar, they can easily dissolve most of the things that water can dissolve as a result of hydrogen. Because by the time any solute gets in contact with alkanol as a solvent, you'll be able to form a bond which can easily be dissolved by the hydrogen bond. Now, what are the reactions? Common reaction of alkanols. There are several reactions, but these are three major common reactions. Number one is oxidation of alkanol. So since we've seen types of alkanols, alkanol is divided into three, which we have seen. Each of these classes also undergo oxidation, but not all. Like primary undergo oxidation to form two main organic compounds. Number one, alkanals, and number two, alkanoic. So in the presence of an oxidizing agent, it forms alkanal, which is also known as aldehyde, and form alkanoic acid, which is also known as carboxylic acid, upon further oxidation. But in secondary alkanols, the presence of oxidation will only brings about secondary alkanols to form alkanone, which is known as ketones. Tertiary oxidation has no effect on tertiary alkanol. So that is why you must find a way of knowing examples of primary, secondary, and tertiary. So in case you are asked in exam and given an equation, so you will know the product that will be formed once you are able to lay hold on different types of the organic or different types of compounds that can associate themselves, that can be categorized into primary, secondary, and tertiary. So we also have the hydration. The hydration is just the removal of water. So when you take, for example, you have ethanol. When you remove water from ethanol, H2O, two molecules of hydrogen and one molecule of oxygen, it forms what we call alkene, or known as ethene. If it is ethanol, it forms ethene. If it is propanol, it forms propene. If it is butanol, it forms butene. If it is pentanol, it forms pentene. That is dehydration using H2SO4 as a dehydrating agents, we also have another prominent reaction known as esterification. This is just almost the same thing with neutralization, but in form of neutralization we have acid plus base to form salt and water, but this one is alkanols, which is organic base, reacting with alkanoic, which is organic acids, to form ester and water. Ester there is just an organic salt. Why the salt form in inorganic, that is salt, but this ester here is just an organic salt. But in another word for ester is alkanoid, which you find majorly in most of the fruitful juice, in fruit juice, in you see any insect that has any scent, you always find this alkanol there. So what are the uses of alkanols? It is used as fuel. It is used in the preparation of organic acids such as carboxylic acid. It is used as a methylated spirit. It is used in brewing industry during fermentation. In conclusion, with OH group in alkanol makes alkanol to possess some basic properties as in inorganic bases such as solubility, neutralization, but the salt is known as ester in organic compound, commonly called esterification, colorless, hydrolysis, and dehydration. Now, looking at this brain T cell, these are structures, and you are asked to write the name of reaction involved in each step. We have step 1. This is propane. This is propane. Give rise to propane. What type of reactions occurs here? So we have the propane. Then when you add it with chlorine and UV lights under the presence of light, it gives what is called chloropropane plus hydrochloric acid. What type of reactions? And so on and so forth. You have to do that and send it to me through Google Classroom. Thanks.